We were talking about sequencers. Well, I thought of this little program, plus give us an example of the use of the fill and the copy. And I know this could be done a little easier, but I wanted to show how we would use the instructions. What does the fill instruction do?
The field instruction?
No.
Well, it could fill almost anything. What it does is fill a section of memory with a constant. So when you look at this one up here, it's filling B10 using indexed address and B10. So indexed addressing allows us to go through automatic locations, right? With what? What's my source? 0. So all I'm doing is clearing out some memory. So if we're going to load a group of memory with any constants, then this would be the ideal place to do it. So it's really neat to use it as a clear, where you can go out and clear out a table. And what I'm doing is I'm clearing out a table before I load it with something. Then we got a copy. So I'm putting this in my B10 register memory location. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then down here I'm copying it. I'm just copying it from my what? From my B10 over to B3. Okay. Everybody understand that? Now, rung number 1, I'm setting up a sequence in B10. I'm going to make that sequence be 10 bytes long, or 10 words long. It's actually words long. Are we okay so far? Everybody understand that? Yes or no? Where am I getting? What's my source for the my sequencer load instruction? Input 0, 0. That's so the MicroLogic 1100 is kind of like the MicroLogic 1000, where both your input ports and your output ports are at module address 0. Okay, and I'm gonna load in the entire word. Input 0. Now, RSLogix won't let you get by with just putting in colon 0. You have to specify the word address when you're doing the input. Of course, this guy's going to reset R6, which will reset my sequencer. Right now, we're pointing at what? Precision 0. Okay. And then rung 3. This is going to copy the contents of my B10 table into B3. Which is pretty neat, because what it'll do, it'll give me the ability to load another sequence while this sequence is running, which is really neat. This is also going to reset R61. We'll see that we're not in here yet. And then we'll come down here, and by the way, the thing's running right now. So I'm using a timer, just for the heck of it. See, it's running right now. And then I'm going to use B3. It's going to keep up with my sequence. I'm going to mask it with 000L. So what I'm going to do is I'm going to strip over these. I'm going to strip off these other 2 nibbles. These other 3 nibbles. I'm sorry. Then we're going to output this out to output 0, word 0. I'm using R6 for the control register for this. I'm going to go length, and right now it's on position 1. Of course, my motor's not doing anything because I've got nothing in the table. Are you okay? Yes or no? So this is a cute little program. So let's set up our table. What do we want? We'll just do something that's pretty straightforward to start off with. So what I'm doing, I'm inputting. From input 0, I'm inputting into my sequence I would have normally put a start stop on this thing so I could kill the whole thing, but I ran out of switches. So that's why the thing is just running right now. It's just like what I do is if I want to stop it, I just clear out the table. So what I'm going to do is bring up B10. That's where we're putting it at first, right? Okay. So here's my B10 register. And we want to set up a sequence. Let me clear it. Okay. Okay, everything's cleared out. So what I'm going to do is I'm going to, we got 10 locations and it's going to take a, so what I'll do is I'll start off with the motors turned off. Now let's go ahead. So I'm going to load in one motor. Oh, sorry, here we go. This is my load. I got to remember what my switch is for. Okay, so we're going to run the first motor, and then I'm going to turn it off. We'll run the second motor. I'll turn it off and run the third motor. Oops, wait a second. Start it again. So we'll start the first motor. Oh, I'm only clearing 10 addresses, by the way. I was wondering. Then we'll turn this motor off and we'll run the second motor. And we'll run the third motor. And we'll run the fourth motor. I think I messed up again. Let's try that again. I must hit the copy button. So we'll set up the sequence. Let me clear out the sequence again. And we'll clear out the memory. Okay. And this should be the first sequence.
B1010 segment 5.
What's that?
B1010.
Yeah, but when I clear, I'm only clearing out the first 10 bytes.
Oh, okay. Okay. 0 to 9.
Yeah, so whatever was there, it's going to stay there. But when I hit that clear, what we'll see is it clears out the first 10 bytes. That's all I'm using for my table. And then we'll come up and decide what we want to do with the first motor. Get all these things. Okay, there we go. And then we load it with a 5, which is this guy right here. Okay, so that'll be the first sequence. Then we'll turn off this motor and I'll load this. Then we'll turn off this motor and I'll load that. Then I'll turn on this light. So I got a light hooked up, and then we'll load that. And then what I'll do is I'll stop all the motors, and then we'll run all the motors. What step am I on? 5. Okay. And then we'll turn everything off on sequence. Okay, so that's my sequence. So if we look at B10, what happened is it put my what in there? Put my sequence in there. And I'm only using the first 4 to figure out where this comes from. But that's okay. Now, what I'm fixing to do is I'm fixing to copy that into what? B3. So what we should see is when I copy this into B3, we should transfer that over. So here's the B3 register. Okay. And what we're going to do is we're going to copy that over. How do I copy that over? I'm going to load the sequence. I'm sorry. Clear the table. I'm going to copy it over with 6, which will be discovered there. I didn't clear the sequence. You should. So what we're doing now is we're down in here. So there's my timer. And after 10 seconds, we have it set up the time sig. What it do? It goes to the next sequence of the table. So that's where I turn them off. Thing next, we turn them all on. Oh, we missed the light, so this is all off. So we're using one light, and that turns it on. Yeah, that turns everything on. That turns all my outputs on. And then what should happen next is we should turn them off. You should set the time for 5 seconds.
How you know it's actually copy it in?
Because it's running. I don't know what maybe I don't understand your.
So all you did is went to the B3 file and changed over.
Yeah, what we did is we went in, and first we cleared out, we can clear out B3, that's what you need to do. I'm sorry, B10, clear it out first, right, understand. If you don't clear it out, and you don't use all 10, then it'll keep the next, it'll keep whatever's in there before. So we're using the file, or I'm using the file field to do what? Just to clear out that B10 that I'm using. And then when I'm doing that, I could actually be reprogramming it right now without it, with it still running the previous program. Y'all understand that? So let's go back and reprogram it. So I'll come back up here so y'all can see. So first thing I'm gonna do is clear out B10, which is okay because I'm using B3 to actually run the program, right? You understand that? So I'm gonna come up here and hit this switch right here, and I just cleared out B10. So if I look at my B10 register, it's what? It's all zeros. So now I can start loading another sequence. So let's turn motors. What we're going to do is going to turn these two motors on, and we got the light off. And I'll go here and I'll load that sequence. Oh, I need to reset first. Okay. So I'll come up here and load this sequence. Okay, and then what do y'all want to do next? I mean, we could come up here and flip them around, right? And I'll load this sequence. And then I'll come up here and turn them all on, and I'll load this sequence. Then I'll come up here and I'll turn them all off, and I'll load that sequence. And then I'll come on and I'll turn on my light. I'll load this sequence.
Well, what about the load tape that's above that line above that?
What do you mean?
The line above that, it says load tape. I thought. I never read, you kept saying load and sequence.
With zeros. What happened is I should have came back. As I was writing the thing, I realized that I needed to do some, and I set up labels and you pulled in a label for it. So that should actually be a clear table.
Oh, okay.
So what that does is it clears my table.
Oh, okay.
And then I can have the ability to do what?
Load.
Load it. Okay. And this gives me the ability to clear my table before I load it. In fact, I should probably, I could save one of my inputs if I put this in parallel with the field. Clear. Are we okay? I'm gonna turn all of them off, but what I'm doing is I'm setting up my next sequence, right? While it's still doing what? While it's still running the last sequence. And of course, if I don't fill anything up, of course, as soon as I transfer it over, it should start running this sequence. Okay. So I've got my table loaded up. So what am I going to do? So now I've loaded up my table in V10. Well, my program is actually running out of V3. So what I'm going to do now is I'm going to transfer it over to what? V3. Well, as soon as I hit 6, push button 6, now it's running the other program. Okay, you'll see that I just got through programming. So I can come in and I can clear it out now. So what I did is I copied it into V3. So there it is in V3. Okay, y'all understand? But now I could come back and do what? Well, I can come back and clear out. I could come out and clear out my sequence load. Yeah, and then I could clear out this guy right here. And then I could go back and start loading what? My next sequence. So this is pretty good. So what I've done is I've set up a programmable sequence, which is pretty good to me. But like I said, I could probably got rid of a run. I can't because normally when I clear out my V10 that I'm using for my positions, I should go ahead and reset this sequence right there. So that would be one change that I would make that I just picked up. And the problem is I just added this morning. So this is just an application of a sequencer. It's really, really neat. So what does a sequencer give us the ability to do? It gives us the ability to automatically go through tables. Right? Y'all understand that? Automatically go through tables. Sequencer load allows us to set up a table in sequence. Now you got to understand, you got this copy right here. So you can literally have these tables set up and just copy a different table into your sequence. Which is a pretty neat aspect of the people do. You can understand how many lines this would take out of a program. So if I wanted to do this, all these different combinations, then we would have a lot of lines, right? You understand? But a sequencer gives us the ability to replace it. If we got something that runs in a sequence, then this would be the guy to what? To use. Because we could replace 256 runs with one sequence. Pretty neat. And you could parallel these things, by the way, and use two different tables. But we could actually output 32 outputs at the same time.
What is bold 1768? On inputs out on the copy sequence, input.
This is the processor that automatically has read automatically. I hadn't figured out how to get rid of that. Even when you put in comments, this won't change. But this is a processor number that automatically sticks on every sequence. Logic Pro doesn't do that anymore. By the way, there's another thing that I remember. You remember things. This is probably one of the worst things I hate about Allen Bradley is you have to do what? Scroll through all those things. But you got this guy right up here that says instruction set what? Palette. Guys, you can pull the whole instruction set down and just put it off to the side, and you can pull stuff out of here just like you do what? Just like you go through all these things up here. which is pretty neat. Now down here, they're in alphabetical order too, which makes, and it's going to use the mnemonic for the instruction. So these are all mnemonics, all mnemonics, which are called, the definition of mnemonic is a memory driver. So I would just read it. Of course, you have to know the mnemonics, and most of them you probably know. But instead of having to come up here and do yeah, go through all those things up there, trying to figure out which category they put it in. Like the reset. Where do we use the reset? We use the reset all over the place. I mean, we use reset. We can reset control registers. We can do anything we want to. But it's inside the counter. I think I had problems finding the big shift instructions and that kind of stuff. It depends on where they put it at. Some of the places they put it in Logic Pro are not available. By the way, another thing is that once you establish one of your processors that you're using, notice the instructions that are not available to that processor are grayed out. So you know right off the bat what instructions are available to the processor. Now this is the 1100, but so if you got the MicroLogic 1000 or the 504, and if you bring this down, it gives you your whole list of instructions that are available. Another thing that's available also is help, and you can get instruction help. So you can bring up an instruction, and what does it do? It brings up the same palette, and then you can come up here and just, if you wanted information on the sequencer load instruction, then it comes up and gives you all the information about that instruction. Okay. So that's built into the 500 logic also. Another thing I wanted to show you with RS Logics, we tried it the other day, but this seems to be, Logic Pro, this seems to be working out okay, is the sequencer compare. Let's see if I put it. Oops. Don't look like I uploaded it. Let's see if I put it here. No, I wrote one. That one don't work. You know, we had problems with it finding things in the table. I'll upload that. It's on my computer at home. I just forget to upload them when I do them at home. I'll show you that next slide. So we got 3 sequencer instructions. We got sequencer load. We got sequencer compare. Sequencer output, right? So you got any questions on that? So when's our next test coming up? Monday. Monday is test 3, and then Wednesday is final exam. Right?
Let's go over that sequencer and
sequencer load with an and mask. I guess it would be. Yeah, so what I've done is I've got a mask. And of course I would have some problems maybe because of course this program wouldn't give us that much problems. But when we use the sequence output, we have to establish what we call a mask. What's a mask? Yeah, where you strip off stuff. The OR mask, make sure bits are set in your answer. The AND mask, make sure bits are clear. And of course, what I'm doing is I'm using hexadecimal right here. And what I'm doing is I'm only using 4 switches. I'm using 4 switches. I'm using 4 switches to control the sequence. So what we have on this thing is we have 10 inputs. And we've got 6 outputs on this guy. So we got 10 inputs, 0 through 9. And then we've got 6 outputs, 0 through, we got 5 outputs, 0 to 4. But if you had a bigger BLC, they would have more outputs. This guy's got 2 analog inputs on it, which is really neat. If I get time, I'll write something to show you how we could actually input analog information into a program, which is pretty neat. So what I want to do is I want to strip off the bits that I'm using to control the sequence, right? You understand that? So I'm using bits 4 or 5. I'm using bits 4, 5, and 6, and 7. The input bits 4, 5, 6, and 7 to actually control the program, right? And then I'm using inputs 0, 1, 2, and 3 to set up the sequence. Right? You understand that? Yes or no? So when I load my sequence, when I load my sequence, I'm getting in all, so I'm getting them in from input 0, word 0. Okay, y'all understand that?
Yeah.
Well, I'm not using all those bits. I don't want all those bits to be sent to my output port. Okay, so what bits do I want to see? I can actually do my mask. I should do it a little different. It would still work. So when I come up here, I've got my inputs. So I'm not using these. So these are not used. But if they've got something in there previous, it could be in there, right? You understand? I'm using these bits right here to control the program. And I'm using these for my sequence.
Cool.
So which ones do we want to strip off? If I'm going to send it to the output, which ones do I want to get rid of? The first, well, not the first, those right there. I want to get rid of all those. Because I'm using these inputs to control the what? Program. I'm using these bits right here to set up my sequence. So I've got 4 sequences. I've got the 3 motors and this red light right here. Okay, you understand. So I'm using 4 outputs, and all the rest of them I don't want go into an output port, because I might be using my output port, my other output ports for something else, right? You understand. So what I want to do is I want to strip these off. So I want these to always be 0 in my answer, right? You understand. And I want these to come through. These are what I'm outputting. So what's going to happen is no matter what's in these bits, when I send this to my output port, I'm going to get this, right? And then I'm going to get the condition of my switches. So my mask would be 0, 0, 0, L. And what that does is strips all the bits I don't want to go to my port, right? You understand? And only lets the bits go to my port that I'm actually controlling.
Okay, just so I'm clear, if you were only using 3 switches, you do 0, 0, 0, 7.
That's exactly right. And we could have used more. I don't have enough switches up here. So I've got 5 push buttons, but one of them's a normally closed push button. And here we don't want to use a normally closed push button. And then I've got 4 switches up here. So I was using the 4 switches to set up my sequence. I don't know if y'all saw me that before. And I was using these 4 push buttons to control the sequence, when I clear, when I don't clear, when I load, when I copy over to my other register. I'm using those switches. So if I wanted all of them to come through, I would use F, 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 F. If I wanted to use these ports up here for something, so let's say I was using these ports up here. I was using, like you're back on the 504. Well, your 504, you got a 16-bit output module, right? You understand that? Well, you don't want to clear out those outputs if they're being used by another program. So we might go what? We might go F, F, 0, F. And what this would be, it would let these other output ports stay the same. They would be with whatever the last program set it up, right? You understand? And then these guys right here would actually update. So you come up with that mask where you want things to come through or you want to strip things off. ORs strip off with ones, right? You understand? ORs, if we got a 1 in an OR mask, my answer would be 1 no matter what the other bit is. So it all depends on what you're trying to come up with, right? Does that make sense?
Which one is the old mask? Which instruction?
OR. Yeah. So normally your move with mask, your mask to move, and your sequencer uses an AND mask. So the MVM, which is the mask move. Since it's MVM, it pops in my head, move with mask. I think the book calls it the mask move. It uses an AND mask. And the sequencer output command uses an AND mask. If you want everything to come through, then you'd use all else, right? Understand that? And normally we use hexadecimal there instead of decimal, because decimal would be very, very confusing, because you would have to take the decimal number and convert it to binary, or take the binary number and convert it to decimal, because it is a binary mask. It is not a decimal mask, right? So we use a hex mask. Now, how do we identify a hex? We just I enter the number and I put an H out here. And give us a hex mask. I'm not sure if RS Logic will let us do a binary math, but it's a binary math. Math, and you put a D out here if your PLC supported.
So you have to designate every time,
What's that?
whether it's hex or binary.
Well, once you did it once, I'm not sure what this takes for positive. We can do that. The program's still up there. We can see what it takes for granted. And like this is the 1100 PLC. So we're offline. So we can come up here and go to our mask, which is down here. So let's put in a number. And we'll enter. And of course, it's going to take that. It took that as hex. So it looks like no matter what you enter, we could enter. So what I did was I entered a decimal number. I entered 15, which I know is what? F, yeah. 255 is FF. So we can see it. So even if I enter in decimal, it's going to show hex. Let's see what it does if we tell it binary. It turned it to what? Hex. So that was pretty cool. So you could enter it binary. You could enter it in decimal. You could enter it in hex, but automatically it comes back and converts your number over to what?
What about octal?
Let's see if what's that umbrella used for octal? Sometimes they don't put O because sometimes they use different letters because O and 0 look so much alike. But we'll try. So let's put, and then we'll put, oops, I didn't want to do that.
Output, 0:0, right? Looks like it worked. So O is octal. It's just that when we some PLCs won't let you use O, like the Siemens. I don't know how Siemens specifies octal, but I know when it specifies an output, it uses what? Huh? Step 7, the Siemens software. Uses Q. Yeah. So Siemens uses Q for outputs because why? Because it's so easy to get the what? The 0 and O computed. Anybody ever did that when you were trying to put forward things?
Yeah.
Yeah. All the time, yeah. So, even me. And like I said, what we'll do, but I'll bring it in when we lab next week. So no matter what base we entered in, we specify the base. So if you don't specify the base, it says I got a rung error. Let's see, error rung 5, address must be specified to word level. Okay. So I put a slash there. So we can't use the sequencer to generate a bit. We got to use it for on the word level, right?
Yeah.
Just if it clears it. So y'all got any questions on sequencer? Very, very powerful instruction. And like I said, if you're in a plant and they're doing something in a sequence, right? And this would be the guy you would use. Just think about the number of instructions. So I'm setting up a sequence of 10 different things in the table. But I'm basically doing it with, when I go through the sequence, I'm doing one instruction, which is really, really good. And sequence compare, like I said, I set up a program at home and it works beautifully, by the way. Of course, where's it at? At home, yeah. So, I tried to upload these. I did all these at home, too. Only one change that I'll see, that I'll come in and make is, I'll move, I'll clear out this anytime I come up in, when I fill. Anytime I fill, when I'm clearing out my 10 spots in my B10 register, I'll also reset my load, which has worked out okay. So that would save me an input. But everybody okay on these masks?
I'll read up on it.
On the run number 5, look at run number 5. It's up under number 4.
Okay. Yeah, this is 5 is my timer, I think, and it's actually going through the sequence. I thought about putting a push button out there.
So why do you have a examiner if on number 5? You see, you got to examine.
It's not a push button; it's a timer contact. So when the timer gets done, so these are timer done contacts.
Right.
When the timer gets done, it automatically drops out. I'm using an on delay timer, so if it times out, it resets itself, right?
Right.
It's going to do this every 10 seconds. And every time it's done, I go to the next sequence.
Oh, okay. Okay.
So what we're doing is we're going to the next sequence every 10
Every
seconds.
time. Okay. It takes the power off the sensor.
Yeah. Yeah, this is on the, I think this is on the low to high transition, but you get semantics of what's going on. So what happens is when it turns off, as soon as the done clears, it comes back on, right? So we get a low to high transition every 10 seconds. Anymore, we can go back online and do something, Rich. And it's running. I just turned off the power supply, so we and I'm not going to say that. So see, it's going, and then when it gets through, it's going to go to the next sequence. Now, sequencer, once you get to the link, it automatically goes back to the top of the table. You don't have to tell it to do that. So the next sequence, this right here, will go back to 0. And then we're going through the sequence again. And y'all can hear it up there, the relays and that clicking. This guy's got it's got a relay output. And what advantage do relay outputs have?
Relay output? It allows us to start heavy voltage for control.
We can what?
We can control heavy.
Type of voltage.
Yeah.
We can do DC, we can do sync, we can do source. So when you look at the outputs, every output has a common. And that's why they're limited with the number of outputs they can put, because they're trying to do it on the same side of terminal block that they're doing our inputs. Our inputs use 2 commons, and they go in groups for this PLC. And the MicroLogic 1000 is the same. So the MicroLogic 1000, some of y'all are doing, has relay outputs on it. And that's why if you could actually hear them click, you can actually hear those little relays, those little read relays clicking. And all these books, by the way, are up there. I need to get the ones on the other PLCs we have down there. It would be nice to get them out and play around with them. And Nancy is ordering some Siemens PLCs, by the way. Of course, that'll be after y'all gone. So most of your manuals come with 2. You usually get a controller manual, and then you get an instruction set manual. If we're looking how to wire it up, then we're going to do what? Then we'll look at the controller manual. And odds are it's going to be wiring up our controller. Then usually has the specs too on the different types. So we have several types. This is something that we haven't gone over very much, and this is noise suppression. So on the AC load, the AC load would use the Virector. This is another network. This is a surge suppressor. If we're using any type of solenoid or relay coil on a DC module, we need to put what we call a flyback or counter EMF diode on there. So if you was over there looking at the Siemens PLC, you'd look on every contact that controls a solenoid would have this diode across it. And I don't know if I've got stuff over here to demonstrate what these coils will put out when you turn them off. So what happens is that when you turn them off, all that magnetic field comes collapsing back into that coil and produces an extremely high voltage. When you take AC, we'll use a neon. When you take AC, if y'all want to take it, we have a 7 Henry inductor that we charge up with 12 volts, and we turn it off. When we take the power off, we turn on a neon bulb that needs at least 70 volts to light up. So I mean, I charge it to 12, but when I turn it off, it kicks out at least 70 volts. So these relay coils, when they come into DC, you're going to have to, or these solenoids, DC depends on a lot of wire because the only resistance that coil has is what determines the resistance of a conductor? The thickness.
And
what?
The length.
The length.
The length, yeah.
Yeah, and the temperature. The temperature goes up, resistance of wire. We got a temperature device called an RDT, which is a resistive temperature device that deals with the resistance of the wire changing with what? for temperature. So if you're gonna put 24 volts DC across a coil, and you want it to pull, 100 milliamps, you're gonna have to use a lot of wire. So you can tell the difference with AC coils and DC coils right off the bat. DC coils are gonna have a lot of wire because that's the only way they get their resistance. What determines how much voltage you get out is the strength of the magnetic field that you have in there to start off with. Okay. Then it's going to be the next thing that determines is the speed of the motion, okay, and the number of turns of wire. So this is why you get such a big kick out of DC coils when you turn them off, and they will wipe out solid state devices in a heartbeat if you don't suppress them. So let's see what we got. This talks about the different DC modules. So this is the one that we've got. I think it's the B. I think it's the next one. Yeah. So this is the way the actual module is set up. So one side's our inputs and one side are output. The inputs, we have 10 inputs, 0 through 9. We have 2 analog inputs. That's what these guys are right here. They have their own common. And then we have a common for 4, 5, 6, 7, 8, 9. And then we have a common for 1, 0, 1, 2, 3. What are we going to hook up to the common? And then it's got a DC power supply that we use for the inputs. We don't use this internal DC supply just to run outputs. We use it for run input. Okay. What do we hook up to DC common? Do we hook up plus or do we hook up minus?
Minus.
Somebody say this could be wrong. It depends on whether you want the input to be syncing or whether you want it to be sourcing. But the way Allen Bradley does on their fixed PLCs is that you can hook them up in groups, right? You understand? So if I take the minus and hook it up here, then these inputs would be syncing. If I take the positive and hook it up here, then these inputs would be sourcing. Now, most fixed PLCs, on modular PLCs, you either buy a syncing input or you buy a sourcing input module. But on most of your Allen Bradley PLCs, you get the ability to change that over. Now, on my output terminal, I've got a common for every output. And they're relay outputs. So what do I hook up here? Well, I can take this AC neutral right here. Now, this is Alabama Power. And then I can run it right here. And then my inputs would be AC inputs. My outputs would be what? AC outputs. Or I can take an external power supply and if I hook a minus up to here, then my inputs would be what? My outputs would be syncing. If I take power and hook it up to here, then my outputs would be sourcing, which is what I'm doing. But what's nice about this is that, or you can make one output an AC output, you can make one output a syncing output, you can make the next one right to it what? A sourcing output. So if I wanted to use this to reverse a little small motor, I can make one of them syncing, one of them sourcing, and make sure they never turn on at the same time. But that would be easy to do.
Now, on the inputs, can you hook them all syncing or sourcing?
Yeah, all we do, if I'm hooking up all syncing, then I will put a jumper from here to right there. If I want to hook them all sourcing, then I put a jumper from here right there. Okay. Normally our inputs are syncing and normally your outputs are sourcing. So if you look at the 504s, the SIG 504s, if you look at the two modules, the input module, written on the module says syncing and the output module says, well, sourcing. And these are DC outputs. Now the only time we're worried about syncing and sourcing is if we're using DC. If you're using AC, if you got an AC device, then syncing and sourcing doesn't even come into play. You understand? It's just that, and by the way, they're calling this L1, this is neutral. Normally we'll have a jumper going from here to here, right? Or grounding. And then normally we will use this as our common. And then that way we can have AC outputs, which is pretty neat. And they'll come down here, this is in the manual. So somewhere in here, they'll give us the specifications, and here they're talking about, the commons, right? Oh, this is AC, by the way. So this, our inputs are what?
The input, source.
No, well, the devices, you're right, the input ports. We have the minus hooked to the common, so these guys are what? Well, syncing. We got the minus to the ports themselves. So this is the common for the ports right here. So if we have the minus hooked up to the ports, then my input ports are syncing. And then up there, when I hook up my input devices, I have the plus up there, so my inputs are actually hooked up. My devices themselves are hooked up to source. Y'all understand that? If you take digital logic, we talk about syncing and sources all the time. But as syncing, we use the minus as common. Sourcing, we use the plus as common. So notice all my switches up there have a common. Common is just a point that we use to connect everything to, right? You understand?
Right.
And they're connected to positive. So I have my input, the device itself sourcing, and I have my input syncing. Y'all understand that? People get confused about that. Down here, we're using sourcing inputs. We're not talking about the devices, we're talking about the what? Input ports itself. So notice here I've got my positive to the common on the input. So these guys right here are hooked up to do what? Source. My devices themselves are hooked up to do what? Sync.
Is one better than the other?
No. And normally, and like we said, normally the inputs deals with what type of sensors you hook up to the thing. So when you got sensors, most of our sensors are electronic sensors. And they're either going to give us an output. What do they give us as an output? Well, a PNP sensor would give us a positive as an output. So we'd have to hook those up to source, right? An NPN sensor would give us a negative as an input. So we would hook those up to sync. So it all depends on what sensors you buy and use in your system. Of course, here we talk about limit switches and all this kind of stuff, but when you get out there, we might have limit switches, but now the predominant sensors are electronic sensors. And they're going to give you a DC. Most of your sensors are DC. We got some sensors back here that are DC, and what they did, since our motor controls is 120 volts AC, and what they did is they put little relays on the modules themselves. So we can plug them into 24 volts DC, and then the output of the sensor turns on a relay. But all this is in the hardware book that tells you, what's available and what you can use, how you can hook up things. Of course, you need to know which version of the PLC you have. So we got one version of this PLC that's AC. So this version right here, if you get this guy, it's what? AC. So that depends. Like we said, when you're dealing with AC, syncing and sources don't come into play.
But shouldn't the AC be on the line one part, on the L1?
It is L1.
Yeah.
This is L2. Usually in motor controls, we call L2 our common, and we call L1 what we call, in house wiring, we call that hot.
Hot, right.
Yeah, so in house wiring, we have what we call a neutral and we have a hot. Okay. L2 is the line that you establish to be as your common. House wiring, you got no option because that's connected to ground inside your meter box, inside your panel. But you determine, once you come through a transformers don't bring ground to, then it's up to you to establish what you want to use for L1 and what you want to use for L2, but you'll have to establish a common, right? Y'all understand that? In DC, it depends on what you want to use for L1 and what you want to use for L2. And I think sourcing inputs are very predominant over, I think they said Japan when I was doing some reading. Over here, our predominant type of inputs are predominant is sync. But, you know, it depends on what type of sensor you hook up out there. What do you want to hook it up with? If you're going to hook up a push button, syncing and sourcing makes no difference, right? You understand that? If you're going to hook up a solid state sensor, then you need to know by George what type of output that thing gives you. You wouldn't hurt the sensor if it was hooked up backwards, but you would never get an input. Right? That makes sense? Any more questions? So these are just different variations depending on the model of the 1100 you have, and you got the same thing inside now on your modular PLCs. The only thing you got on your mechanics is the PLC itself, and then you would go out and get a selection guide, and then this would tell you all the modules that are available to you. So when I go over here and look at my I/O modules, then depends on how many inputs you have, what do you got AC, what do you got DC. So notice these set of modules, these are all what? Sourcing models. These are all syncing models. These are syncing models. These run on 24 volts. We got some that runs on 5 volts. We got this guy right here. Syncing module. This guy can run on 125 volts DC. Alright. 48 volts DC. So it all depends what's available in your plant. AC is pretty easy to change the voltage level going through a transformer. DC is not. DC you usually get what you got, right? You understand that? So if your plant uses high voltage DC, then instead of you trying to go down to 24 volts, and so y'all understand this? These are all input modules too. So these are all input modules that are available to you. And these are AC modules. So you can see they come in and then they split them up and actually give you the syncing modules, each one by themselves, and then they give you the electrical characteristics of the thing. So these are all syncing. These two run on 24 volts. These three run on 24 volts. This one runs off 48 volts. This is 125 volts. This is 24. I'll tell you how much current they pull, right? Backplane current, backplane. So this would depend, if you buy the wrong modules, they don't give these things away. Of course, the module number is actually, if you wanted to look up the specs for the module number for the ones on the 504 back there, the number is where at? Right. Yeah, you open up the little door that covers up your I/O connection. Yeah, and it'll come up and tell you that, which you need to know. You need to know when you set up a new program. Any more questions? So these books are available. We have the 504, the Slick 504 manuals. We have the 1000 manuals up there. We got the 1100 manuals. These manuals are free from our. That means it's no excuse when you get out there that you don't get the manuals that's available for your for the PLCs, because they're free. And sooner or later you're gonna have to use them. Okay, so you might as well just go ahead and figure out what they're using and go ahead and get the manuals and have them available.
We used to have to take the module analog card and open up the back of it and set these switches there all the time before we use it, because you put it in there and if it ain't programmed for that type of switch,
or for the voltage levels, the type of voltage you're measuring. Yeah. Usually, some of those cards are like that. If you're in if you came up through PCs and tracked them things from when they first became available, you would understand configuration switches. Because just about every port you put inside that computer, you had to set the address for the port, you had to set everything.
Especially for
Well, serial ports were just as bad too. And the sound cards and all kind of stuff, you had to set the resources used by that card when you put it in your computer. When they came out with Windows XP, they came up with something called PNP, which is plug and play, where the card contains all this information in it. And when you plug it in, thank goodness. I mean, because how many times have you plugged a USB thing into your slot and a little box pop up there and it says installing information about that? Well, that's what you're doing. And USB assigns addresses and all that other kind of stuff automatically. When Allen Bradley PLCs though are, and even then the addresses you get are assigned by where these things are at, right? You understand? So when you get a modular PLC, the addresses they get are assigned by which slot you put that thing in. And I wish we had time to do communications. The book does a pretty good job on what we call the data highway, which is a method of communication. But it talks about Ethernet and it talks a little about that. So, you know, odds are you get into a real big plant, they're gonna have all these suckers what? They're gonna have hooked to each other. And that way you can go in there and you can select a node. When you say who's active, right now when we say who active, the only guy that says it's active is this PLC. But what'll happen in that, when you look at who's active, what will you do?
Show you the station.
It'll show you all the stations out there. And you can go to an individual station. Yeah, pick a station, download the program off that, play around with it, go to the next station. And all these guys can communicate with each other, which is pretty neat. We had time to do that, guys, but so Allen Bradley uses what they call the data highways, the 485 and then the data highway plus. And then the new PLCs have Ethernet on them, which is becoming very, very, very popular. Ethernet. The Siemens uses one called Profibus that which is very similar to the 485 interface. It uses the Gen 9 pin. Odds are when you get out there in a big application, they're going to be connected together. And it still looks about the same. What you can do now is you can just plug into the bus on any other PLCs and do access all of them. They could have it networked to, they have adapters that take the data highway and converts it over to Ethernet. So you literally could have an Ethernet connection in your office and access all the nodes out there in your plant. I think somebody was telling me about some guy making changes from his home.
Yeah.
Which is, you know, with virtual private networks gives you the ability to access a network from a remote location. You can do that.
He was playing with it at home.
Yeah.
It was online. Next thing I know, the line went down. So I'm like, why the line go down? Say, anybody touch that? Nobody touch that.
They said
Then nobody touched that. Then we kept looking, trying to find out why the line went down. Trying to find out he was at home. Playing around with the system. Shut the whole line down.
Guys, you can come up here and look and see how this is wired. It's hard to tell because it's just kind of nest egged up here using all these jumpers. But I think the inputs are hooked up to source. The input devices themselves are hooked up to source. The outputs are hooked up. The output devices are hooked up to sync. But if y'all ain't got any more questions,